little question here. It says, consider a graph of instantaneous power versus time with the vertical axis straight and starting at p equals 0. What is the physical significance of the area under the p versus t curve between the vertical lines t1 and t2? How could you find the average power from this graph? Okay, so what does that area mean? All right, so if I take the integral of this, what does it tell me? So if I integrate a power function with respect to time, so if I multiply this t over here, so instead of having an average power, I would just have an instantaneous power. I would get the work, meaning the area under the curve is the work. If it's a straight line like this, in order to find the average, I would just take the final minus the initial, divide it by 2. If this was a curved line, I would have to then go, all right, find my integral, find the work, take the work divided by my time interval to get my average power. Either one would work. Part B on this one says, draw a p versus t curve that consists of two straight line sections for which the peak power is equal to twice the average power. All right, so give this a try. You can just pause the video here and then come back. All right, so one that works here is just a nice triangle where the peak is here and halfway down is the average. So I see that, this peak, if I cut it in half, it's a nice symmetrical thing, like this little part goes over here, this little part goes over here, perfect. And I end up with an average power equal to half of the peak, or total power, or max we'll call it. So that would be an example you could use.